Hello, everybody. My name is Michael Mattis. I'm an enterprise account engineer here with Amazon Web Services. And today's webinar will be on implementing Amazon workspaces for high security environments. So, a lot of customers, when they initially start their cloud journey, and specifically with Amazon workspaces, they have obviously a lot of questions on where to start. Workspaces, when they think about securing it, traditionally comes down to most customers look at applying operating system patches, updating third party software that's on the Amazon workspaces itself. What we've done in terms of this workshop or this webinar is we have broken it down into five specific areas of focus. The first focus is on securing the endpoint. This would be the device that is used to connect to the Amazon workspace itself. There is securing the control plane, and the control plane is more so the workspaces administrator or the AWS account owner or administrator who is provisioning workspaces on behalf of the end customers. So, in a large organization, this might be a central cloud team or a central cloud office. The third aspect of securing Amazon workspaces would be securing the data plane. This is the actual traffic, whether it's PC over IP or the workspaces streaming protocol or any network traffic that is flowing between the customer environment and AWS. The fourth aspect is securing the workspace itself. And this is where most customers are used to their tried and true practices of, again, applying operating system updates, securing third party software, making sure that they're running updated versions of third party software. And then the fifth aspect is securing the directory itself. And this is often an overlooked aspect. And I like to think of you can't actually have a secure workspace until the directory itself that the workspace is authenticated against is secure. So we'll touch on that as well. And then at the very end, we'll have a hands on workshop. And in that, I will be touching on a few of the different aspects of securing workspaces, such as securing the control plane, securing the data plane, and securing the directory. So, expanding on securing the workspaces, all the bullets in this particular slide focus on one of the five areas that I mentioned in the prior slide. We talk about directory security. This could be things such as making sure that you have the appropriate encryption algorithms allowed or disallowed for your particular directory. MFA, so the MFA stands for multi-factor authentication. This could be not only multi-factor authentication to the AWS account for the central cloud team or the person that's provisioning the Amazon workspace, but this could also be applied to allowing multi-factor authentication, whether it is through YubiKeys or through smart cards to the Amazon workspace itself. IP routing. So again, a lot of customers want to control not only how they can connect to their workspace, but where their workspaces themselves can connect to. So IP routing could take one of two different areas there. Client certificates. Client certificates we're probably not going to elaborate on too much in this webinar. However, Workspaces does allow the ability to have a third-party certificate authority or a customer managed certificate authority issue certs down to client devices. And that's one way to constrain which client devices can actually connect to the Amazon Workspaces endpoints. Log forwarding. This could be not only for the directory itself, but also log forwarding from the workspaces themselves so that you have central log collection of what's going on inside the guest operating systems. Volume encryption. This is, I would say, often overlooked by a lot of customers. Workspaces does have the ability to integrate with AWS KMS so that you can simply select a customer managed KMS key to use to encrypt the EBS volumes that are associated with their Amazon workspaces. The domain credentials that are used to actually launch the workspaces and join those workspaces to the Active Directory domain. The group policies on the target Active Directory domain, and the organizational unit to which those workspaces will be become a member of. The Workspaces security group. This is the stateful firewall that's going to be attached to the network interface that's associated with each Amazon workspace that is part of that directory. And then over on the right-hand side, again, we're talking about Workspaces internet connectivity. Again, that kind of comes back to that third bullet over on the left-hand side, IP routing. So in this particular case, we're focusing strictly on network connectivity. where workspaces can connect to themselves. Authorized clients. Workspaces does have the ability to constrain or control uh, which client you can actually use to connect to your workspace, whether they're Windows devices, Mac OS devices, Linux devices, web client, zero clients. User rights within the workspace. So by default, when you provision a workspace, there is a checkbox to either allow or disallow the provisioned user to have local administrator access on the workspace itself. For high security environments, by far and large, almost every customer should be deselecting that and saying no, they do not want their users to be local admins on their workspaces. Authorized and permitted IP ranges for clients. And again, this is again constraining who can connect and where they can connect from. User self-service permissions. This is an interesting one, and I see a lot of customers that are allowing their end users to be more self-service in determining whether they can upsize or downsize the Amazon workspace that they have provisioned for themselves. Custom image or maintenance on the image itself and the software installed in the image. This gets back to, again, a lot of the tailored maintenance that customers are used to doing, whether it's applying operating system patches, third party software updates on the guest operating system, whether it's Windows or Linux based. Password complexity requirements that are associated with the Active Directory accounts. And then clipboard redirection. This is, I would say, highly overlooked. It is very, very beneficial, especially if you have customers or clients connecting in from untrusted environments into your trusted corporate environment. You can either allow list or deny list them the ability to redirect something from their local clipboard to the workspace or from the workspace outside of the environment, thereby preventing data exfiltration. This is a busy slide, and I'm just going to hit on some of the high notes here. If you look over on the left-hand side, you have a customer site, and you have users in their corporate data center, and down in the bottom left-hand corner. And I'll just kind of trace the data flow from end to end here. So the user is in a customer site. They're on a client. We'll just say a Windows-based workstation, and they authenticate over TCP 443. That traffic flows over the public internet. It hits an AWS managed public endpoint. That public endpoint is an authentication session gateway. That auth session gateway is then going to broker a connection to the customer's AD connector. And again, in this particular diagram, we're assuming that the customer has deployed Active Directory either on EC2 or they're authenticating against Active Directory that is located back on premises. So in this particular case, the customer has AD connector deployed in an AWS account. That AD connector then has an elastic network interface that allows it to interact with the customer's domain controllers. And in the bottom, you will see that Active Directory can be replicated on AWS. By far and large, I have not seen a lot of success with customers deploying Active Directory on premises and not extending that Active Directory into AWS with the usage of workspaces. In other words, if you're using workspaces in AWS, you absolutely should be extending your existing Active Directory domain or deploying an Active Directory domain inside AWS. That will allow you to achieve the best and optimal authentication experience. So as that authentication happens, it hits Active Directory. Active Directory validates the user's credentials. Those credentials generate a Kerberos token. That token is then assigned back to the user identity, at which point all authentication has happened, and then the user is going to open up a second TCP and UDP session, and that is where the streaming gateway IP. So over on the left-hand side, you can see the streaming gateway IP with binary ones and zeros. So that all is happening over, in this particular case, it's happening over PC over IP, which is TCP and UDP ports 4172. That traffic also flows over the public internet. It is encrypted. It hits an AWS managed streaming gateway. And then that streaming gateway then has an elastic network interface that allows it to interact with the customer's Amazon workspaces which is in an AWS managed account. And then the customer's Amazon Workspace also has an ENI that allows it to communicate with Active Directory, DNS, other EC2 instances, or anything else that's inside a customer managed VPC. So this was a very brief overview of securing Amazon Workspaces. Best practices for deploying Amazon Workspaces is going to go in significantly more depth. It is about 40 plus pages long. It is a very good read, and it is updated very, very frequently. I would say quite a few times per year. I believe it was last updated in June of 2022. And with that, I will cut over to a demo where I will walk through some of the steps that I talked about so that you can actually properly secure your Amazon Workspaces for a high security environment. Okay, now we're in the AWS console, and I'll show you actually how to properly secure your directory. And so the first thing we'll do is we'll go to the Directory Services console. So right here, I'll just click on my recently visited menu. Now I've already gotten a directory provisioned as part of this hands-on lab. This directory is configured with all the default settings. The directory name itself is workspaces.labx.com. What I'll do here is I'll just click on the directory ID. From here, I will scroll down. I will enable log forwarding here. And what I'm doing here is I'm creating a new CloudWatch logs group that's then going to take the logs from the domain controllers and forward them to this CloudWatch logs group. This is useful for auditing and security purposes. I'll click on enable here. And that will take somewhere between 5 and 10 minutes for those logs to be available in CloudWatch logs. Now what I'll do is I will go down and I will configure SNS notifications. And that's in the maintenance tab. Directory monitoring. I will create a notification here. And I will create a new notification. And these notifications will alert you of any health issues when the status of the directory changes. So obviously, if the directory is of paramount importance for Amazon Workspaces, as that's the directory that users authenticate against, if there's a health change with the directory, the administrator or the operations team should know about it. So ideally, you would configure an operations team email list in this recipient chain, and then they would be notified anytime that the status of that directory changes. So there, we'll go ahead and click create there. And now we'll register the directory so that we can create Amazon Workspaces. So here, we will actually go to the search menu and we will click on the Amazon Workspaces logo there. And that's going to launch the Amazon Workspaces console. In here, we will click on Get Started Now. And here you're presented with two options, either the quick setup or the advanced setup. We're going to go ahead and click the advanced setup and click Launch. Now in the select directory type, I'm actually going to cancel out of this because I already have a workspace or a directory configured, and it's an Amazon managed Active Directory. So I will go ahead and click cancel here. And then that will back us into the Workspaces console and the list of directories. And I will click on the directory here, click on the radio button. I will click on Actions, and I will click on Register. Now I need to register that directory with a couple different subnets. I will register with this subnet. As you can see, that is US East 1A. In this section, we're going to register the directory with two different subnets. Those subnets will be 10.0.10/24 and 10.0.20/24. So I will go ahead and select that subnet, and I will select the other subnet. And in this particular case, just for the purpose of this workshop, we are not going to enable self-service permissions, and we will not enable Amazon WorkDocs. We'll go ahead and click register there. Okay. And now it says it successfully registered the directory. This now enables us to launch Amazon Workspaces. But before we go ahead and do that, now what we're going to do is we're going to select the directory and we're going to update the details so that we can actually pick the appropriate organizational unit and all the specifics with the directory for our Amazon Workspaces. So I will select the directory here. You will see the registration code and all the other settings that are associated with the Workspaces directory itself. In the target domain and organizational unit, we will click Edit Target Domain and OU. We will select the Computers OU. We will hit Save. Access to Internet. We will edit access to Internet. We will just make sure that that is disabled. This does not necessarily mean that Workspaces cannot access the Internet. It just means that they must go through an outbound service or system to access the Internet. In this case, this workshop is going to leverage a NAT gateway for the Amazon Workspaces. So the Workspaces themselves will be deployed in a private subnet inside the Amazon VPC. In access control options, we will go ahead and select Edit Access Control Options. And here's where you can allow or disallow specific devices. In this particular workshop, we're going to say that our organization is a Windows-only org. So we will allow all Windows devices. We will deny all Mac OS devices. And we will deny all Android or Chrome OS devices. The option here for Root Certificate 1 and Root Certificate 2 is relevant if you have a certificate authority as part of your organization's hierarchy. Then you can issue machine certificates that can be deployed to your trusted devices to only allow machines that have those certificates on their local certificate store to authenticate to the workspaces themselves. We will hit save there. And then there's an option here for endpoint encryption. If we select edit here for endpoint encryption, by default, it's going to be TLS encryption mode. If you are an organization that has FIPS 140-2 validated requirements, such as a US government organization or the United States Department of Defense, you can select the radio button for FIPS 140-2 validated mode and click Save. For the purpose of this workshop, I'm just going to keep it as TLS encryption mode. But again, select the appropriate encryption mode based on your organization's requirements. The local administrator setting down here, if we click on Edit, make the user a Workspaces administrator, we are going to deselect that. And then the IP access control groups, We will skip that for now. We will come back to that at a later point. Self-service permissions, we will update those settings there. We will deselect Remember Me, and we will deselect Restart Workspace from the client. All right, now we'll go back into the IP access control group setting, and we'll start over on the left-hand side. Over on the left-hand side, we clicked on IP access control groups. We're going to create an IP group here. We will call the group name Corporate Office. And we'll give it a description of IP range of corporate office. And like most things in AWS, you can apply tag values. We will leave that blank for the purpose of the webinar. Now what we'll do is we'll select the IP access control group that we just created. And we will click Edit. And we will add a rule. And what we're going to do here is we're going to add specific IP address ranges of our corporate network. And the IP address ranges that we define here are the only IP ranges that are allowed to connect to the corporate workspaces. In this particular case, I'm going to assume that my on-premises environment, my corporate CIDR range is 128.0.0.0/8. I will call this corporate HQ for headquarters. We now need to associate that IP access control group with the directory. So if we go back, to the Directories tab within the WorkSpaces console itself, and we click on the directory ID, we should be able to click on Edit IP Access Control Groups. We can select that IP access control group, and we can select Associate. Now at this point, once we associate that IP access control group with the directory itself, only IP addresses within that CIDR range that we defined as part of that IP access control group will be allowed to connect to WorkSpaces. Another part of securing the WorkSpaces environment is securing the directory itself. And what we've done so far is we've updated log forwarding, we've updated SNS notifications to alert us when the health of the directory changes. We've configured the Active Directory OU that the WorkSpaces will be joined to. But now we're going to go ahead and update the encryption settings on the directory itself. Now we're going to go back to the Directory Services console and update the encryption settings to specify the specific encryption protocols and ciphers that are allowed for our Amazon directory. So here we will select Directory Service. We will select the directory itself. And here at the directory settings down here, you can see the various encryption protocols and the cryptographic ciphers that are enabled for that directory. We will go through and click on Edit Settings. And what we will do for this particular workshop is we will disable everything except for TLS 1.1 and AES 128/128. So we will go through and disable all of these other protocols and cryptographic ciphers. Disable. We will review our settings, and we are effectively disabling everything with the exception, again, of TLS 1.1 and AES 128. We will click on Update Settings. Now, up at the top of the screen, you will see a notification. The settings on the directory itself is being updated. It will take approximately anywhere from 30 minutes to a couple hours, depending on the number of domain controllers in your directory. In terms of this workshop, I just provisioned 2 domain controllers as part of my AWS Microsoft Managed Active Directory. It should take anywhere from 30 minutes to an hour for that to happen. Now that we've provisioned the directory, we will move forward to actually launching an Amazon Workspace and adjusting the directory settings and the configuration in the workspace itself to be more secure. So we will go back to the Amazon Workspaces console. And we will click Launch Workspaces. In this particular menu, you can see the directory that you want to launch the workspaces in. We will use the workspaces.labx.com directory that we already previously created. Because we're using AWS Managed Active Directory, we get the ability to create Active Directory users at the same time that we provision a workspace for them. And that's exactly what we will do in this specific scenario. So we will create one for Image Builder. We'll call it Image Builder SA with the first name of Image Builder. Last name Service Account. And an email address. We will create the user. By clicking that button, that will create the user in the directory itself. This module is all about creating a customer managed KMS key, creating an IAM policy to allow Workspaces administrators to use the key, and attaching an IAM policy to the IAM role that the Workspaces administrators assume when they perform their duties. Customers in regulated and high security industries generally prefer the use of customer managed KMS keys rather than AWS managed keys for the following reasons. Customer managed keys offers customers the ability to have full control over the KMS key, including establishing and maintaining their key policies, IAM policies, grants, and enabling and disabling of keys, rotating their cryptographic material, the addition of tags, and creating aliases that refer to the KMS keys. Customer managed KMS keys can be used in cross-account scenarios. What we'll do now is we will go to the key management service console itself. And here at the KMS console landing page, we'll click on Create a Key. We will leave the default option for symmetric. You must use symmetric keys if you want to use KMS keys with Amazon Workspaces. And we will leave the default for encrypt and decrypt operations as well. We will go ahead and click Next. We will give the key an alias, and in this particular case, we will call it Workspaces Workshop Key. And then in the description, we will call it KMS key used to encrypt Amazon WorkSpaces. We will click Next. In this menu, we're defining the key administrators. These are the people who actually have access to the KMS key and can administer the key through the KMS API. In this particular example, we will select EE Overlord and the EE Overlord role. And the key usage permissions, we will select Team Role. And here you can see the key policy and the other configuration settings that are used for that particular KMS key. Here's the default key policy with an option to add additional actions or principles to this particular key policy. We're going to leave it as the default for now and select Finish. Now we will modify the IAM policy associated with the Workspaces administrator's IAM role such that they have permission to use the KMS key in their account. Since we are using a customer managed key to protect our Workspaces data, in addition to the permission in the key user section of the default key policies, Workspaces administrators need permission to create grants on the KMS key. Also, if the Workspaces administrators use the AWS Management Console to create workspaces with encrypted volumes, Workspaces administrators need permission to list aliases and list keys. For that part of the workshop, we will go to the Identity and Access Management Console, otherwise known as IAM. We will select Policies on the left-hand side. And in the Policies Filter section, we will filter by simply typing Workspaces. We will expand the Workspaces Admin AWS Managed policy. We will click on the Copy button here to copy all of that JSON to our clipboard, and then we'll create a new customer managed policy from that. And for that, we will click on Create Policy. And instead of walking through this visual editor, we will just go right to the JSON tab right here. We will highlight that, delete it, and paste in all of the existing content which we had previously copied from the default AWS Managed Workspaces policy. Now we will add in the following lines to our Workspaces administrators to create grants on the KMS key. So for that, we will add in an allow action. We will add in an action. That action will be KMS create grant. And then the resource will be the ARN, or the Amazon resource name, of the KMS key that we previously created. Now, if you don't have the ARN handy, you can open up a new AWS console in another browser tab. Go to the KMS console itself. Click on the customer managed key. And then here you can see the ARN. I will click on this button that will copy that ARN to the clipboard. I will then come back here and paste that in. With that, we will click on Next. We will not add a tag to this. We'll click on Review. And we will give our policy name Custom WorkSpaces Admins Policy. We will click on Create Policy there. And now that we've created that custom policy, we will attach it to the IAM role being used by our WorkSpaces administrators. So on the left-hand side of the IAM console, we will click on Roles. And if you remember, there were key administrators and there were key users that we defined for that particular KMS key. The key users were, the team role was a key user. So we will select team role here. And then in the permissions policies window, what we will do is we will click on Add Permissions. We will select Attach Policies. And then we will select the checkbox next to Custom WorkSpaces Admins Policy. We will scroll down and select Attach Policies. And the policy is now attached to the team role. Now that we've updated the team role to include the ability for the WorkSpaces administrators to create grants against the KMS key, we will jump back to the WorkSpaces console itself and provision our first workspace. We will select Launch WorkSpaces. We are going to be launching it in the workspaces.labx.com directory. So we will click Next Step. And here you can identify users, or we can select users from the existing directory. Let's go ahead and click on Show All Users and see which users are part of the directory. In our example here, we will go ahead and we will provision a workspace for a new user. We will call that new user Image Builder SA with the first name of Image Builder and the last name of Service Account. That just created a new user in the directory. We will show all users. And now you can see that the list of users has changed to reflect the addition of Image Builder SA to the directory itself. We will select that user. We are going to provision just a workspace for them. We will select next steps. In this menu, you get a view of all the different bundles that you can select, and which bundle you choose is going to be based on organizational preference. In this particular example, we are going to provision a workspace that is standard with Windows 10 Server 2019 based PC over IP. Down at the bottom, you can see the root volume for the operating system is set to be 80 gigs and the user volume is set to be 50 gigs. We will leave those as the defaults and select next. You have the option of choosing your running mode with each Amazon workspace. In this particular example, we are going to set the auto stop time for 4 hours. In the encryption section, this is where you can select via a checkbox whether to use a customer managed KMS key with either the root volume or the user volume for each Amazon workspace. In this particular case, we're going to select the customer managed KMS key that we created as part of this workshop, which is called WorkSpaces-workshop-key. And we will use that to not only encrypt the root volume, we will also encrypt the user volume as well. We will select next step. We will verify our settings here. And you can see the checkbox that the root volume and the user volume are both encrypted with this particular encryption key. And we will select the button to launch the workspace. Now you'll get this little pop-up here that says the workspace is being launched. Unencrypted workspaces take approximately 20 minutes to become available inside the AWS console itself. Workspaces that are encrypted will take approximately 40 minutes to become available, as the note indicates. Now that you have provisioned a workspace, once your workspace is up and ready and you've successfully connected to and authenticated against your workspace, you can actually check those CloudWatch logs to make sure that log forwarding did happen. And the way that you would do that is you would use the CloudWatch console, and the CloudWatch console has a section called Log Insights. And we will expand the log section over here on the left-hand side. And we will select Logs Insights. What we do here in the Logs Insights console is we actually select a log group to query, and then we specify a set of statements that can execute against that log group and retrieve a set of results. So in this particular case, we're going to select the directory log group. So that would be workspaces.labx.com, if you remember. And we will then go through and update our query to include the information that's relevant for this specific workshop. In this particular case, what we want to do is we want to grab the IP address of the workspace to check to see who authenticated against it and when they authenticated. So in this particular case, I will open up another tab and grab the IP address of the workspace. And that will be in the Workspaces console. In this particular section of the Log Insights console, we're going to input a set of statements which we will use to query the workspaces.labx.com CloudWatch logs group to ensure that a user was successfully authenticated against their workspace. So we will leave the fields at timestamp and at message. We will then add another row to apply a filter where at message like, and we will call this event ID 4624. Event ID 4624 is the Microsoft Windows event ID for a successful logon event. Event ID. We will then add another filter where at message like, and in this particular case, we would input the IP address of the Amazon workspace in question. So in this particular case, if we know the Amazon workspace has an IP address of 10.0.1.125, that is what our statement would look like. We will apply yet another filter where we're going to be looking for a particular user of interest. And in this example, we will use image builder underscore SA. We will sort it in descending order, and we will limit it to only 20 results. So when we hit run query, what we're doing is we're querying that CloudWatch logs group to see if image builder SA logged in to the workspace that has the IP address of 10.0.1.125. And we could tell they logged in by event ID 4624. So as you can see here, there were 19,543 records, 0 results, which means Image Builder SA has not logged into their workspace yet. Now, later on, once the user authenticates and has access to their workspace, if you were to rerun this query, you would see results return in this CloudWatch logs group query. Okay, now we have a Image Builder SA has an Amazon workspace that is standard available to them. Now what we will do here is we will expand the workspace. We will grab the registration code. We will copy it to our clipboard. And assuming you're on your endpoint device that you're using to connect to your Amazon workspace, we will launch the WorkSpaces client. We will input that registration code. We'll click on register. As you can see that the device is not authorized to access the workspace, and that's because the workspaces directory was configured with an IP access control group to only allow IP ranges falling within the 128.0.0.0/8 IP space. I've since deleted that IP access control group just for the purpose of this scenario. So I will go through and register this new directory with the WorkSpaces client itself. And you can see it's now popping up an authentication prompt, at which point I will input a username and password. And in this particular case, the username is going to be image builder SA. And the password will be a password that was created by me. So when I provisioned the Image Builder SA workspace, if you remember, it asked for an email address associated with this identity. That email came into my mailbox. There was a link within that email. I clicked the link and input the specific password that I wanted associated with that Image Builder SA account. So I will now use that password to sign in to the workspace. Because this is the first time the workspace is actually logged into, it may take about a minute or two for everything to become available. Now that we're in the workspace, what we will do is we will configure the PC over IP encryption settings and the clipboard redirection to ensure that we're using the strongest encryption algorithms that are available and to prevent clipboard redirection from the guest operating system in the workspace outside. And so for that, we will go to the Start menu. We will click on Edit Group Policy. Ugh. Jeez. All right. What do I need to do here? I need to update this. Sorry, I need to make another quick change. So now Image Builder SA has an Amazon workspace that's available to them, and we registered that registration code with the Workspaces client itself. Now we're going to go ahead and authenticate to the workspace. So we're going to input Image Builder SA and the password that was created when the account was set. Now this is the first time that Image Builder SA has logged into this workspace, so there may be about 10 to 15 seconds extra of configuration that happens the first time the profile is loaded onto the workspace itself. Okay. Now what we're going to do is modify the local group policy on this particular workspace to deny specific cipher suites, and we are going to prevent clipboard redirection. And we will do that by launching the local group policy editor. Edit group policy. And once the local group policy editor is open, we will full screen that. We will expand computer configuration, administrative templates, PC over IP session variables, overridable administrator defaults, and then PC over IP security settings. In PC over IP security settings, we're going to select the radio button for enabled. We will select TLS security mode for maximum compatibility. And then we will modify the blacklisted cipher suites, or what we shall say the deny listed cipher suites. And we will deny list anything that is not AES 256 Galloy counter mode with SHA-384. So what we will do is we will and it's a semicolon separated list. So we will just append a semicolon to each of these. And we'll just take these first 4 cipher suites at the bottom as an example of how to deny list those particular cipher suites. And then PC over IP data encryption ciphers. We will select AES 256 GCM only. And then we hit apply and select OK. Now what we will do is we will also configure clipboard redirection. And to do that, we select configure clipboard redirection here, double click on that, and select enabled. And then the options are, as you can see, disabled in both directions. That prevents the endpoint from redirecting data into the workspace itself, and also the workspace from redirecting data back out to the endpoint. That is the most restrictive setting. For high security environments, this is by far and large what the majority of customers do. So we will select that, and we will select OK. So now that we've configured clipboard redirection and prevented bidirectional clipboard redirection from a client to a workspace itself, we will test it out in practicality. And to do that, we will open up the Notepad application within the workspace. We will input test clipboard, and then we will go out of the workspace to the local client, and we will dump the clipboard contents. And you can see that the clipboard contents were just of the local clipboard on the endpoint itself. And previously, what was in the clipboard was the registration code for the Image Builder SA's WorkSpaces registration code. So you can see that that test clipboard did not get redirected out. And if I were to highlight the registration code from the endpoint here and try and paste it into the workspace itself, that still does not paste. The only thing in the clipboard in the workspace itself is what I had previously copied, which was just the text test clipboard. So that just illustrates a quick example of how to prevent clipboard redirection to the workspace and outside of the workspace, as well as controlling which encryption algorithms are allowed for the streaming of traffic to the Amazon workspace. And in this particular example, for today's webinar, we used PC over IP, but the same policies are also applicable to WSP Workspace Streaming Protocol as well. Well, everybody, I really appreciate your time today. It was greatly appreciated. We'd love to hear your feedback on the webinar. If you do have feedback, you can email me directly at mattsm at amazon.com. And if you have other ideas or topics that you'd like to see discussed further about Amazon Workspaces, again, feel free to reach out to me, and I'll be sure to either take that feedback personally or relay that to the appropriate team members inside AWS. That way we can continue to innovate and deliver the best experience for you, the end customer. Thank you very much.